Everyone, my name is Atharv Chauhan, and in this part of presentation, I will be talking about one of the most important data pre-processing steps in data science, normalization techniques. This helps us ensure that all features in dataset are treated fairly, especially when they come in different scales. Often in dataset, different features have completely different ranges. For example, age may range from 18 to 60, while income may range from 1000 to lakhs. If we directly feed such data to a machine learning model, the features with large values automatically dominate the learning process. So the normalization helps us bring everything to a common scale so the model doesn't get biased towards high magnitude numbers. This is especially important for algorithms like k-means, KNN, SVM, gradient descent, and neural networks. Now, when normalization is essential, normalization becomes absolutely necessary when we are using machine learning models that depend on scale. We are applying distance based methods. We are comparing feedback ratings in different ranges. We want to avoid one feature overpowering other feature. In short, if your model uses distance, gradient descent, or mixed scale data, normalization is a must. Now, min max normalization. Min-max normalization is the simplest, most intuitive technique. It compresses values into a fixed range, usually between 0 and 1. It's perfect for rating systems, image pixels, any feature where values already fall in a fixed boundary. A big advantage is that it keeps the shape of the original distribution, but the main drawback is that it is very sensitive to outliers. Even one extreme value can shrink all other data. Now, the standardization, Z-score normalization. Z-score normalization transforms the data so that it has mean 0 and standard deviation as 1. This way, each value shows how many standard deviations it is away from the mean. We use Z-score when the data follows a normal distribution. We need statistical interpretation. Features have different units like kg, meters, rupees, etc. This method is widely used in statistical analysis and linear models. Now, Z-score using mean absolute deviation. When dataset contain many outliers, standard deviation is not the best choice because it squares the errors and gives too much importance to extreme values. In such use cases, we use MAD based Z score. MAD stands for mean absolute deviation. Mean absolute deviation is more stable, more robust, and not easily influenced by outliers. Use MAD when the dataset has extreme values, the median makes more sense than the mean, the sensor errors or inconsistent measurements do exist. This was the whole picture about Z score using mean absolute deviation. Let's talk about decimal scaling. The decimal scaling is very simple method. Here we repeatedly divide values by 10 until all values fall below 1. For example, it is if the largest value is 987, then we divide by 1000. That is 10 to the power 3 to bring everything into a smaller scale. It's fast, easy, useful for quick magnitude reduction, but it's not as precise as others methods. So it's rarely used in modern machine learning. So, how do we choose the best normalization method? If you have outliers, we have to go with mean absolute MAD based Z score. If you need values between 0 and 1, we use min and max method. If we need standardized data, we use Z score. And if we want something extremely simple, use decimal scaling. There is no single perfect method. Your choice depends on the dataset and the model you plan to use. Talking about the key takeaways, to wrap up, normalization is crucial for machine learning and data pre-processing. It prevents scale differences from affecting model performance. Min-max Z-score, MAT-based Z-score, and decimal scaling are the four core techniques. Always choose your method based on outliers, range needed, and algorithm requirements. Thanks for listening. I hope you like my video. Thanks for watching.